There are several isomers with the formula C6H16N2. One is shown below. Give the number of peaks in the carbon NMR of this isomer. So we need to find all the different carbons. So these two carbons are the same. We can see that they're on the chain. They're different to these two because these two are closer to the nitrogen, but they are the same as each other. And then we've got this one here, and that would be unique comparative to this one here. So they're all our carbons. We've got 4 different colours for carbons. Then it wants the splitting pattern of the hydrogens labelled A. So remembering that splitting is about going next door. So no next door neighbours this way, 2 next door neighbours this way. And when we're doing splitting, we're using the n+1 rule. So 2 + 1 is 3. So we're looking for a triplet. Okay. And why are we going to get in a triplet? There are 2 H's on the adjacent carbon. n+1 is 2 + 1 = 3. So now we want to say nylon 6,6. Now nylon 6,6, the 6 refers to the chain of carbons. So we're going to have 6 carbons in a row with the amine groups at the end in order to allow us to join in a polymer structure. So I've done 4, 5, 6, and then another NH2. Draw the structure of the isomer that has 2 primary amine groups and only has 2 types of carbon. It's a bit tricky, this one. So 2 primary amine groups and only 2 types of carbon, but 6 carbons altogether. So it's either like 3 and 3 or like 4 of one and 2 of the other, something like that. 2 primary amine groups. So we want to have an NH2. We want some symmetry. Really, the only thing we can probably do is put 4 methyl groups identically, and then the 2 C's that have the methyl groups are the same as each other, and the 4 methyl groups are the same as each other. 2 tertiary amine groups and only has 2 peaks. Okay, so to be a tertiary amine group, the N has to have 3 carbons coming off of it. And we've got 6 carbons altogether, and we kind of need to mirror that to get that symmetry. So we only have 2 carbon environments.